Lesson 11.2 is an infinity of sinusoidal functions. So in 11.1, we introduced sinusoidal functions as part of our section on periodic functions. They repeat over time. So now we're going to look more in depth. The first thing we have is a principal axis. So the principal axis is the line that's directly in the middle of the range of the function. So if you look at the graphs of f of x equals sine of x here in green and f of x equals cosine of x in pink, you'll notice that the x-axis is right directly in the middle all the way through. So that's the principal axis. If it's been shifted up or down, you can find the principal axis by finding the average between the max and the min, adding them together and dividing by 2. Next, we have the amplitude. The amplitude is the distance from the principal axis to either the maximum or the minimum point. And we always say it's a distance, so we call it absolute value of A, and it's the difference between the max and the min, the distance between the maximum and the minimum, and dividing that by 2. So if you take the parent function or an untransformed sine or cosine function, they both have the range of -1 to 1. They have a domain of all real numbers. Their period is 360 degrees. The principal axis is at the x-axis, y equals 0, and they have an amplitude of 1. If you take something that's been transformed, like this h of x is equal to 3 sine 2x minus 2, it's been shifted down 2, vertically stretched by 3, and horizontally compressed by 2. So the range now goes from -5 to +1. The domain is still all real numbers. The period has been crunched in half because it's been horizontally compressed. So now the period's only 180 degrees. The principal axis is the maximum and plus the minimum divided by 2. So it's y equals -2. And the amplitude is the distance from that to your max or your min, so a distance of 3. So if you have general sinusoidal functions, y equals a sine bx plus d, or y equals a cosine bx plus d, then the principal axis is going to be whatever your vertical shift is, whichever is whatever's being added on to the end. So it's just going to be whatever this thing added or subtracted that I called d. The amplitude is always what your horizontal, or your vertical stretch or compression. So it's whatever is being multiplied by sine or cosine, but we always call it the absolute value. So it's just the absolute value of whatever's in front. If it's negative, that just reflects it across the x-axis. So instead of sine starting at equilibrium and increasing, it'll start at equilibrium and decrease. Instead of cosine starting at its maximum, it'll start at its minimum. And then the period is 360 degrees divided by whatever's being multiplied by x, because that is how much faster or slower that sine function's going. So it's 360 degrees divided by b. So using all that information, we have a graph here of y equals -20 cosine 3x, and we want to find the amplitude and justify why it's the amplitude, and find the period and justify. So looking at this graph, go ahead and pause the video and do number 1. So amplitude is the distance from your principal axis, which in this case is still the x-axis, to a maximum or minimum. So I noticed that that's a distance of 20. And then the period is how long it takes for one whole cycle to repeat. So I looked at one minimum value and found the next minimum value and found that that was a distance of 120 degrees. So that's going to be the period. So for the next example, we have two equations, y equals 3 sine 2x minus 1 and y equals -2 cosine 0.25x plus 4. So using just the equations, find the amplitude, the period, the equation of the principal axis, and the range. So go ahead and pause the video and try those. So for the first one, the amplitude is just the absolute value of whatever's being multiplied in front. So in this case, just a 3, that's your vertical stretch. The period is 360 degrees divided by whatever's multiplied by x. So this is going 2 times faster than a normal sine function, so it's going to take half as long. So it's going to be 180 degrees for one full cycle to occur. Your principal axis is just your vertical shift, so in this case it's been shifted down 1, so y equals -1. And then the range, what I did is I started with the range of a normal sine graph, -1 to 1. I stretched it by 3, which would go -3 to 3, and then I moved it down 1, so I got -4 to 2. So basically it's your amplitude plus your d value. So if you haven't already done so, go ahead and pause the video and do b. So same thing, your amplitude is the absolute value of a, so you end up with +2. The period is 360 degrees divided by b, which would be 360 degrees divided by 0.25, which is 1,440 degrees. The principal axis is just whatever's being added onto the end, your vertical shift, so y equals 4. And then the range is just your principal axis plus or minus your amplitude, so 2 to 6. This last example says that Simon explores the tidal patterns by measuring the depth of water at the end of a pier. He finds that the data can be modeled by the function f of x is equal to a sine bx plus d, where x is the number of hours after 12 midnight. Simon's laptop crashes, but he finds a piece of paper with his data. So we have the time at 3 a.m., which they give us the coordinates as 3:11.2, so therefore the depth of water was 11.2 meters. And they're saying that that was the maximum or high tide. And then at 9 a.m., it was low tide or the minimum, and they gave us the coordinate 9.5, so basically 5 meters. We know it's going to be sine because it's starting at its middle, its equilibrium here, if we look at the graph. So then given this information, determine the values of A, B, and D in Simon's model, and then interpret. So go ahead and pause the video and try this one. So A is your amplitude, so it's the difference between the maximum and the minimum divided by 2, the whole distance divided by 2. So I just subtracted the maximum 11.2 minus the minimum of 5 and got that, and divided that by 2 and got that the amplitude, or A, was 3.1. And it's positive because it starts by increasing. D is your principal axis, so that's the average between the maximum and the minimum, the right in the middle part. So I took the 2, the max and the min, and divided that by 2, and you end up with 8.1. And then B, I found the period by subtracting the x values of your maximum and minimum, but that's only half because that's only going from your max to your min, not your max to the next max. So then I multiplied that by 2 and found that the entire period was 12 hours. So therefore B would be 360 divided by 12, or 30. So then the whole function model would be f of x is equal to 3.1 sine 30x plus 8.1. A, the 3.1, that's the difference from the average depth to the maximum and minimum depth. So whatever the average is, plus or minus 3.1 meters. D is your principal axis, so that is the average depth of the water. So on average, the depth of the water was 8.1 meters. And then B, if you do 360 divided by B, that's the period. So that's how long it takes for one whole cycle of tides to happen. So it takes 12 hours for the cycle of tides to repeat. B itself is how much faster or slower this model is going than your standard sine graph. So this has been sinusoidal functions and finding all the pieces of your sinusoidal functions using given information.